So we have another two speaker today. Dr. M. Sasikala, Professor and Director from Anna University. And another one is Professor Rajbabu Velmurugan. He is from IIT Bombay. So today our session 3 and session 4 conducted by this speaker, eminent speaker, and they will share knowledge about IoT and all the IoT and its applications. So Dr. M. Sasikala title is session title is Role of IoT in Healthcare, and Professor Rajbabu session title is IoT in Agriculture. So very interesting session, I think. So you all have knowledge about gain knowledge about the IoT in different applications. 68 joined. Our speaker is already joined meeting. So let's start, I think. Madam, hello.
Good evening, sir.
Good evening, madam. So
Sasikala here.
Shall we start?
Yes, sir.
Yet 66 have joined. And total strength is about 185. Among them, 136 joined. So right now 66 joined from them.
Okay, I leave it to you. If you want, you can start now.
Okay, we start. Okay.
Okay, sir. Okay.
Okay. So our session number 3 expert speaker already joined our ATAL FDP on Internet of Things and its applications. So I want to give some introduction of Dr. M. Sasikala. She is ME PhD, professor and head of the Department of Biomedical Engineering, Center for Medical Electronics, Anna University, Chennai. She has teaching experience 27 years, research experience 25 years. She has completed the funded project almost 8 patents. There are 4 patents. Publication, national international conference publication are 36. National international journal publication are 32 in reputed journals, SCI, SCIE, and Scopus Index. And she has delivered many expert lectures, course organized, and experience at abroad also. So she will take session of role of IoT in healthcare. Please, madam, start.
Thank you so much, sir. Am I audible?
Yes, madam. Yes.
Can you see the screen?
Yes. You can slide so. Okay. Okay. Now okay.
Now it's fine, no?
Yes. Fine. Fine.
Okay, very good evening to everyone. Uh, so I'll be presenting on the role of IoT in healthcare. So generally, this IoT has transformed the way the medical services are delivered. Generally, we used to go to hospitals or a clinic if we want to do any kind of uh, healthcare monitoring. Suppose if you are suffering from fever or any kind of abnormality, we used to go to a hospital or a clinic and then we will measure our vital parameters only during that time. But now IoT has transformed the way the medical services are being delivered and how healthcare is looked at now. So now using IoT, we can have IoT enabled wearables. So nowadays, we are also using wearables in our day-to-day lives, like smart watches and fitness trackers. So if you see all these smart wearable devices, they measure the vital parameters in real time. Continuously, it measures the parameters, and these wearables are Bluetooth enabled or Wi-Fi enabled. So directly these parameters are transmitted to the Android phone. And from the Android phone, the connection between the smart device, smart wearable device, and the Android phone is through Bluetooth. So the parameters can be transmitted wirelessly through Bluetooth or Wi-Fi to the mobile phone. And from the mobile phone through Wi-Fi, these parameters are stored in the cloud. And cloud, we can have the post processing, very enhanced complex algorithms can be run on the cloud. So from the cloud, information can be given to the clinician as well as to the caretakers. So previously it was that if you want to get some medical services, we have to visit hospitals and clinics. But today that is not the case. So with the help of IoT enabled wearable devices, we have a point of care diagnosis. What is point of care diagnosis? Wherever you are, we can measure all the parameters, vital parameters, and also diagnosis. Some amount of diagnosis is being done in the or presented in the wearable device itself. So this is possible because the sensors and the systems are connected through the IoT. And because of that, you have seamless data exchange between the devices. And this improves the patient care and also efficiency has been improved. So here is a picture where the patient can be connected to the multiple wearable devices. Say you have multiple vital parameters to be monitored. For example, heart rate, blood pressure, glucose, then SpO2, oxygen saturation. So multiple parameters or multiple sensors can be placed on the patient, or you can have a single, like a smartwatch, you can have a single device which measures all the multiple parameters. So this smartwatch, for example, here what is shown is a smartwatch, and this will measure all the vital parameters. So the sensors are placed in the smartwatch and some amount of processing is done in the device itself. Because, for example, if heart rate is measured, so this the heart rate will be calculated from actually in wearable devices, you have indirect measurement of heart rate. Instead of using the ECG electrodes and measuring ECG, they derive the heart rate from SpO2, from the pulse waveform, SpO2 waveform. They derive the heart rate, which is almost close to the pulse rate. So indirectly, they measure the heart rate from SpO2, and we know oxygenation level is being measured. using the plethysmography technique where you have a LED sensor and a photo detector. So it measures the levels of oxygen saturation and deoxyhemoglobin concentrations, and based on that, the partial pressure of oxygen, that is SpO2, is measured. Similarly, blood pressure is also indirectly measured from the photoplethysmography signal. Because you cannot have complicated sensing devices in a, when it comes to wearable, it has to be miniaturized and it has to be worn by the patients or subjects. So mostly indirect measurements, sensing elements will be there, so that some amount of indirect measurements is being done here. And then processing also takes place, and display, minimum kind of display will be there in the device itself. So if you take smartwatch, you have display so that the parameters can be displayed, as well as the parameters can also be transferred through the to the cloud. So it will not, the wearable device will not directly transfer these vital parameters to the cloud. It will be connected through Bluetooth or Wi-Fi. The wearable device will be connected to the smartphone. So nowadays, everyone are carrying the, having the Android phones, smartphones. So through Bluetooth, this wearable device is connected to the Android phone. So this smartphone will have the application. The application will be loaded in the smartphone. So all the parameters that are being picked up by the wearable device will be shown in the both in the display of the wearable device as well as in the app of the mobile phone. So from the mobile phone through Wi-Fi, these data are getting transmitted to the cloud. Okay, once it is going to the cloud, all the parameters are stored in the cloud. So from cloud, you can do more amount of processing. The data can be stored, and then you can do all kind of analytics from the data. You can study the trend for 1 week, how these parameters were varying. Even for a normal person, you can see how these parameters were varying for the whole week. So trend analysis can be done. And if there is some abnormality, you can detect it early because continuously we are monitoring the vital parameters. So early detection is possible. So if there is any kind of abnormality, immediately the doctor will be informed. So from the cloud, these data will be sent to the doctor so that the doctor sees the data and gives immediate attention to that particular subject. So from the cloud, you can connect it to the doctor. The parameters can be sent to the doctor for his to get his opinion, to get the diagnostic opinion from him, and he can give his diagnosis, and that can be in turn given to the smartphone. So the doctor's diagnosis can also be wirelessly given to the uh, smartphone, and these parameters can also be connected to the electronic health records of the uh, patient. So directly the vital parameters can be stored in the health records, patient health records, or it can be connected to the hospital information system. So everything is now automated. There is no manual intervention. So you can see um, in the ICUs or even in the wards, what the nurses will do. Periodically, the nurses will come, measure the vitals, and they will record in a um, record in the hospital sheet, and that will be viewed by the doctor during their visits to that particular patient. Now everything is automated, so all these parameters directly goes and sits in the hospital information system, and directly the doctor can view at any time the vitals of his patient, and he can be in continuously, he can um, uh, provide his opinions to the patient. And all these huge amount of data, when it is stored in the cloud, there is a possibility of developing AI based algorithms, big data analysis. Everything is possible once the data is uploaded to the cloud. So it is found that in the global market, especially in the Asia Pacific region, the IoT in healthcare market size In 2021, it was $89 billions, and it is expected to grow to 446 billions in 2028. So you can see almost there is an increase of 7 times the growth. You can see the projected growth is 7 times from 2021 to 2028. So all the devices that the medical industries are developing, they try to integrate IoT in those devices so that this they can catch the market. So what is the need for IoT in healthcare? So as you all know, continuous monitoring is very essential to pick up the diseases at an early stage. So when we do, so there is a requirement for continuous monitoring and also reporting concurrently. Only monitoring will not be sufficient. You have to monitor continuously, you have to monitor, pick up the vitals, and then it has to be reported continuously to the clinician. So these are all the need of the hour. So IoT, when you enable the device with the IoT, these things will be met by the devices. And next is when you come to healthcare, the most important thing is affordability. We have to provide healthcare and affordable healthcare to all the population in our country. So affordability is very important. So why IoT? Through IoT, how we are able to get affordability? Because when you all these smart wearable devices, they come at affordable prices, and so the long-term chronic patients also can get the wearable devices, and they can keep a continuous watch of their vital parameters so that even if there is a slight abnormality, they can go and approach the clinician. So at home itself, they can monitor the vital parameters. Mostly it will be helpful for the elderly population. So large amount of data is being gathered, collected through these wearables. So analysis is also becoming, because now you know analytics is everywhere. So healthcare data analytics is also important, and that is possible only through the IoT enabled wearable devices. And because of these things, what is important here is in today's world, notifications and monitoring. Notifications, even if you take medications, though we approach the clinician, we are being offered medications, but how many of us take medications at the right time, the right dosage? Because sometimes elders are at home alone, and their kids are in the foreign countries. So, how many of them are taking their medications properly? So, all these things can be automated, and it can be these things can be monitored. So, notifications can be provided as alerts that you have to get medications at 9 o'clock, you have to take these medicines. So, you can get, we can, IoT enabled devices can provide notifications as well as the medications, what medications they have to take and what is the dosage and how much medicines are left over so that it can be filled up. All these things can be done with the help of IoT enabled devices. Next important thing is telemedicine services. We all know what is telemedicine. Telemedicine is getting the consultation of the doctor where the patient and the doctor are, they are at two different places, so that remote consultancy can take place through telemedicine. So generally video consultations, generally they do video consultations because if a patient is in the rural area and they wanted to get some opinion from a clinician who are in the who is in the city, so they can connect through video conferencing so that the clinician can interact with the patient so that they get video consultation. So that will not be an efficient telemedicine service. So here through IoT, what we can do is the patient can be connected to the all these vital parameters or the devices so that in the real time the doctor can see the vital parameters, and so that accurately he can diagnose and he can give us decisions. So the diagnosis becomes accurate. So we can have a efficient telemedicine service because of this wearable devices. And because of all this data being accumulated and stored in the cloud, so a lot of amount of research is now possible. So you can develop AI tools, you can develop predictive algorithms based on the symptoms, you can predict the disease, and you can also grade it. So what are the applications of IoT in healthcare? So, we know remote patient monitoring because you are connected with the devices, wearable devices. So, all the vital parameters such as heart rate, blood pressure, oxygen level, glucose levels, everything can be measured from the place where the subject is there. Either it could be home or it could be a hospital. So, early detection of any kind of abnormality is possible at home itself without so that we are now avoiding the frequent visits to the hospitals because continuously we are monitoring, and only if there is an abnormality we can go to a hospital. So and also we could detect it in early at an early stage. And no smart wearables, many of us are now using all those gadgets like fitness trackers and smart watches everyone are using, and other devices are also now connected to the all the hospital devices are also now being connected to the IoT. So smart wearables, it can give alert to the patient as well as to the doctors if there are any irregularities. So in case of heart rate, if there is any change in the heart rate, so generally the arrhythmias, we have two major arrhythmias like bradycardia and tachycardia. Tachycardia is an arrhythmia where it is higher heart rate, and bradycardia is a lower heart rate when the heart rate is lower than the normal. For example, if the normal heart rate is 72 beats per minute, and if the heart rate is higher, maybe around more than 85, it will be tachycardia, and less than 50, it will be bradycardia. So when continuously the heart rate is being measured, you can easily detect the arrhythmias. And since heart rate is being measured, from heart rate, you can measure the heart rate variability. So that from heart rate variability, we can measure the stress levels. Nowadays, stress is also a very important parameter to be measured because today in the modern world, in every profession and everyone are facing stress, and especially the school children and who are taking NEET exams and JEE. So everyone are in stress, and you can monitor the stress levels also and track the stress level in a week, how their stress levels are there. So all these things can be done at home itself with the use of smart wearables. And telemedicine, I told you, through this, when IoT is getting integrated with the telehealth platforms, you can get timely interventions for the patients. Even medical devices is becoming smart, like the patient monitoring system you have in ICUs can be integrated to IoT, the infusion pumps, inhalers. So all these things I will tell you in detail in the next upcoming slides. But what we have to understand that the medical devices, not only the all these parameters, the medical devices can also be connected to the IoT so that even you can program what kind of dosage has to be given to the particular subject, and also the adherence can be seen whether they are taking up the dosage in the regular in those levels, so that immediately if there is any pattern change, it can be informed both to the caretaker as well as to the it can give alerts both to the caregivers as well as to the patients. And the next important thing is the hospital asset management. You can see in hospitals, we have, if you take a government hospital, a very big government hospital, you will have lot many medical equipment will be available, but they are not able to, even the hospital employee, they are not able to identify the medical equipment because it will be present in many wards, ICUs. So if a person comes into an emergency in the intensive care unit, uh, and then it becomes very difficult to track where the medical equipment is available. Say, for example, a ventilator is required, but a ventilator will be there in some other place, it will be lying idle, because these people, they are unable to track physically, they are unable to track the medical equipment. So if IoT enabled medical equipment is there, you can easily track the location of the equipment, and efficient optimized usage could be there. Effective usage of the equipment can be there. So hospital asset management is also possible by, if you're able to track the medical equipment, because wheelchairs, defibrillator, ventilators are very essentially employed and required in emergency situations. And we know, because if the persons are normal, we will not be minding too much to use smart devices. But for subjects, or for patients who are suffering from chronic diseases, like long-term conditions like asthma, hypertension, and diabetes, these smart devices will be very much useful, so that they can be in continuous monitoring. And emergency response systems, like, for example, fall detection systems. So if this fall detectors are IoT enabled, so whenever there is a fall, you can detect the fall, as well as once the fall is detected, immediately the alarm will go to the caretaker and to the ambulance, so that immediately um, the patient can be attended, because elderly people are alone at home. So even if you have fall detectors, and if it is not IoT enabled, uh, you cannot get benefit out of it. So if the fall detectors are IoT enabled, so immediately when a fall happens, the people, the caretakers, or the responsible people will be the family members, immediate family members will be instantly alerted and reported. And you have even emergency call buttons. So in a critical condition, they will be unable to make a call. They'll be unable um, to go- uh, to go for any help. So in that case, a simple click of a button, we can provide alert messages to the ambulance as well as to the family members. So if you take applications, so point of care diagnosis is possible, because wherever you are, you can do that is point of care. Where so it goes to that particular patient itself, wherever they are, you can immediately, using these IoT enabled wearable devices, you can measure the vital parameters. So point of care diagnosis we are able to achieve, and real time health monitoring. You are seeing your vitals in real time, instantaneously. You can measure all the parameters, so continuously you are monitoring the individuals, so that you can reduce the time, but reduce the hospitalization time. Maybe after post operative, if you want to stay in a particular in a hospital, so what happens, the bed charges will be very high. So instead, if you have wearables, you can be at home, so that continuously you can monitor, so that um, the stay time in the hospital is getting reduced by that. Because of that, the cost, you can cut the cost of the bed charges, or your hospital stay duration can be reduced, so that at home itself you can monitor them. And then personalized health service. Why we say personalized? Because we have a track of all your health parameters continuously. Since they are measured, we have a track of all the vital parameters, how they are varying. And so their personalized treatment plan can be suggested by the clinician for that particular patient, what could be the treatment plan. And as I told you, elderly care, you can have this fall detection systems, and this emergency call buttons, and emergency alert systems. And even the all the smart watches will be very helpful for the elderly population. And as I told you, real-time location of the equipment in hospitals. It's a very important field where we can locate the equipment in the hospitals. And also patient location tracking. So the patient, if they are admitted in a hospital, they'll be moved for various tests. So sometimes the patient will not be there in his room, so that he will be taken for a particular test. For, say, for example, he'll be taken for a ultrasound, or he would have been taken for an X-ray. So it is also important if you have an RFID for a patient, so he can be tracked, so that every time you can have a track of the patient's location. And sometimes even the doctors and nurses are also having these kind of RFID tags, so that they are also being tracked. Their locations are also being tracked. And as I told you, research, because large amount of data now is available, so that you can apply deep learning algorithms, AI tools, machine learning algorithms. So any kind of analysis can be done, so that you can go for a early detection. And this can be as a, you can develop computer aided detection systems. So all this can aid the clinicians. So research, so you have lot of research opportunities in the medical field. And the same thing, big data analysis is, large volume of data is available. You can go for a big data analysis, deep learning algorithms, and you can do and you can automate all the systems, so that you can do early detection as well as grading. You can grade the disease whether it is mild, severe, or you can even do prediction. And even drug delivery, as I told you, drug delivery, on important application is glucose monitoring. So continuously, patients who are diabetic, for them you can continue. There are continuous glucose monitoring sensors, and it is a closed loop system where the glucose levels are not only monitored, the amount of insulin to be delivered is also calculated, and immediately this wearable system delivers the insulin to the subject. So drug delivery is also being uh, is one of the application. And then, as I told you, stress detection. So directly the stress, there are two ways of stress detection. One method is from heart rate variability. The other method is from the EEG signal. So here, mostly generally, they are using heart rate variability to detect the stress. So they will see variation in the heart rate. Heart rate variability is nothing but the difference in heart rate. Um, Heart rate is continuously measured, and their difference is being, uh, or what to say, recorded with respect to time. That is heart rate variability. So using the heart rate variability, we can measure the stress. There are many applications. You can see so many case studies are there. And what is the benefit that we get out of this? So we have seen quite a lot of applications. What is the benefit we get? So we have improved patient outcomes. So because of continuous monitoring, we have timely interventions can be done, so that you don't wait till the emergency situation arises. Okay, immediately you can attend to the patient. So we are reducing the emergency situations. And then enhanced efficiency. As I told you, everything is automated. So previously, the nurse used to write it, all the vitals they used to write in the record. But now everything is automated. If you see, if you have wearables and IoT enabled devices, everything can be automated. And all these parameters can be directly fed into the computer. It can be directly fed into the hospital information system, so that everything is automated, and you are minimizing the manual errors, so that efficiency has been, and also the hospital administration load can be reduced, because there need not be too many uh, people in the administration, because everything is automated. So everything, all these goes and sits in the hospital information system, electronic health record of the patient. So it eases the administration responsibilities of the hospital. And as I told you, cost saving. You can reduce the hospital, your stay in the hospital. Unnecessarily, you need not go to the hospitals. Only when there is a need, you can visit the hospital. So that all this is nothing but reduces the cost. And personalized care, that's what I told you, because your treatment is based upon your data that is being analyzed over a period of time. It is not that uh, it is taken only during the required time. If you are using variables, you will have a entire data over a week or over a month, how your data is there, so that they can go for a customized treatment plan. So as I told you, the advantages: cost reduction, improved treatment, and faster disease diagnosis, proactive treatment. Okay, and then as I told you, you can both manage drug as well as equipment, drug and equipment management, and error reduction. So everything you try to automate so that the manual errors, so all these gets reduced. So IoT for medical devices, this is an example picture you can see. The smart wearable devices, it transmits the parameters to the cloud. So what are the parameters, vital parameters we'll see? All the wearables that we use have heart rate, they have blood pressure, and they have number of steps that you walk. Based on that, it calculates the calories burnt. And SpO2, during the COVID time, we all have used the pulse oximeters, is it not? So we have used the pulse oximeters at home, but we used to, we had a display, and in the display we got the percentage of oxygenation, SpO2 values. Okay, but it was not IoT enabled. But if it was IoT enabled, so all this, a community, uh, the data of a community can be monitored by a clinician, and immediately when there is a fall or a drastic reduction in the SpO2 level, immediately attention could have been given during the COVID time, so that many lives could have been saved. So even if we have IoT enabled thermometers, digital thermometers. So if it is IoT enabled, even the temperature could have been picked up. The fever clusters could have been picked up during the COVID times. And then I told you about the hospital asset tracking. So you can, using RFID tags, we can find out, because if you have an RFID tag for every equipment, and so that using RFID, we can locate where these equipments are placed, so that assets can be tracked, so that efficient utilization, as well as in government hospitals, they don't know how many equipments are there. Again, they will try to procure equipment, so that now they can easily do the asset management. So everything is automated. As I told you, using IoT, you can also do patient as well as the nursing staff can be tracked, and doctors can be tracked in the hospital where they are located, so that immediately you can um, pass information to them in case of emergencies. And you can also see whether the nurses attend their duties on time, whether they are in their particular assigned duties. Everything can be monitored. Then you can also have, using smart, you can also have a smart hospital environment. Even the lighting, everything can be controlled. Say, for example, if a hospital room is not occupied by a patient, so you can have a lighting control. Okay, whenever a patient or it is being occupied, you can have lights. So all these things can be done, and even the temperature can be controlled. For example, you can decrease or increase the temperature of your air conditioners based upon the um, environment temperature. So if you see in the hospitals, they will have a centralized air conditioning systems. But even in the centralized air conditioning systems, they measure the temperature using sensors, and they are all connected to the IoT. Based upon the temperature, automatically the temperature of the air conditioner will be set. It is not manually done. Automatically, it is being set. So this is a representation when a person is in the hospital bed. See how many parameters are wirelessly connected. So starting from the remote health monitoring. So you can have the wearables. So all the health parameters are getting monitored. And I told you about the medication. So this pill, what is it? What do you say? The medication bottles can have RFID tags, and you can have RFID reader. So whenever before he takes the pill, he can show the this bottle on the reader, so that the reader immediately scans and it finds out what is the tablet he has taken, and this information will go to the patient as well as to the caretaker. So if the family member is working, and so he will get immediately an alert message that at 9 a.m. This particular medicine has been taken by the patient. And also the drug tracking can be done. How many pills were there in the bottle, and how many has been consumed, and how many drugs are being left. So that automatically these information, if it is known, you can do the refilling. So drug tracking can be done, and medication intake also can be tracked, whether they are doing properly taking the medicines. And then smart hospital space. I told you the lighting can be controlled. And medical inventory and equipment tracking. So as I told you, if say for example a patient monitoring system is connected here to the patient, so this will have an RFID tag, so that the administration will know that this particular equipment is being used in the for this particular patient. So a smart asset management can be done. So all these devices are connected through uh, the wireless Wi-Fi, and all this information are being monitored. So if you see the IoT architecture, there are different layers in the IoT architecture. One is the sensing layer. The first layer is the sensing layer. IoT device need not be always a sensor as the first layer. It could also be an actuator. So based upon the sensing, we can also give some actuator as the output. So sensors can actuators are the first layers. Then once the sensing is done by the sensors, like a temperature sensor or a SpO2, you have the pulse oximeter, you have an LED sensor. So all these sensing elements will sense, but you need to digitize for processing. So here in the IoT data acquisition system, next stage you will have the data acquisition system, where all these analog parameters are converted into digital. We digitize the parameter, and then once we digitize the parameter, the raw data will not be transmitted, because say for example even the heart rate or SpO2, you have in the wearable device itself, you have the display. So it has to be, all these parameters have to be displayed, is it not? So there's some amount of processing should be done in the device itself. So it is not only digitizing, there should be some processing in the device itself. And it should, so that is here it comes to edge computing, where it does onboard processing. So real-time data processing will be done in the device, and finally the information or the parameters that has been calculated will be displayed in the device, as well as the device, or it will be transmitted through a wireless communication interface. It will be transferred through the Android phone, and from the Android it will be transferred to the finally to the cloud. And these are the various stages in a IoT architecture. So first is the sensing layer, where the physical sensors will be connected to the patient, and the data will be acquired, but it will be in the analog form. It has to be converted to a digital form. So data acquisition system will be there, which will convert the analog data into digital data. Then you have the edge IT system, where edge computing, the pre-processing of the data, and also the parameters will be computed from the raw data that is acquired. And finally, the display will be done on the device itself. And then these parameters will also be transmitted to the Android phone, because Android phone will be having the application. So here you can have only minimum display. In the wearable, you can have only a minimum display, but all the post processing like track analysis, all the analytics, you can have it in the, now all the devices, wearable devices comes with an application, Android application. So this Android application will run in the Apple watches or whatever smart devices, so that all the tracking and um, analysis, all the analytics will be done in the application. And from the Android phone, all the data can be transferred to the cloud. So finally, you can have the post-processing power, because you cannot have high-end algorithms running on the Android phone. So all this high-end computing can be done in the cloud as a post-processing. So generally, what are the different types of wearable devices? We know fitness trackers, smart watches. It counts the number of steps. How these number of steps are counted? We have IMU devices. We say inertial measurement units. IMU sensors are placed in the watches. This IMU sensor will have accelerometer, a gyroscope, and a magnetometer. So put together all these three, we call it as IMU sensor, inertial measurement unit sensor. So it calculates, it identifies the fall or the number of steps that we walk. All the because of the acceleration, we are trying to know the number of steps that is being walked. And you have head mounted display. Even in the virtual reality environment, can be IoT enabled, so that now even the treatment uses virtual environments. And then sports watches. It is not only for the patients, these wearable devices are being used. Widely, it is being used in the various sports fields. When they are in practice, the athletes, when they are in practice, it is very important that the vitals during their sport activity, it is very important to monitor their vital parameters, how the vital parameters are varying during their sport activity. For example, running, cycling, swimming. So we need to continuously monitor how these parameters are varying in the during the sports activity. So mostly these devices are being by the sports personnel. And then smart jewelry. So this smart jewelry is like a ring. For example, rings can be used so that it will not look like a wearable device. It is looking like an accessory, but it has the application of sensing the parameters. So even these jewelries can be considered as IoT. And smart clothing. Now you have electronic textiles, smart textiles, e-textiles. So all these textiles will have the sensors inbuilt in the clothing itself, so that if it is enough if you just wear a jacket or a fabric, which will have all the sensors in it, so that just like a fabric, you can wear the jacket and go to and you can carry out your normal activities, so that these uh, these sensors will continuously measure and transmit the parameters. So having given all this introduction, what are the parameters, various parameters that can be monitored is listed here. For example, heart rate, the blood pressure, respiration rate. For blood pressure, I told you. For heart rate, it uses photoplethysmography technique. From the pulse waveform, the heart rate is being measured approximately, not from the ECG signal. In the conventional systems, generally from ECG signal, heart rate will be measured. But in the case of wearables, you cannot have such a kind of uh, what to say, hardware to measure the ECG signal. So the plethysmography signal, from the plethysmography pulse signal, the heart rate is being measured. The pulse rate is being measured, which is equivalent to the heart rate. And blood pressure, even blood pressure is measured indirectly from the photoplethysmography signal. And respiration rate here, respiration rate is measured by using belts. We have belt that can be worn in the abdomen. So when we breathe, when we inspire and expire, you have our lung volume changes. So when you wear this belt in the chest or in the uh, mostly in the chest, what happens? The expansion of the lungs can be measured. So directly that can be useful for the respiration rate. And the biomechanical parameters, as I told you, the accelerometer, the gyroscope measures the angular velocity, accelerometer measures the acceleration. So all the motion sensors. So generally in the market, it is called as motion sensors. These motion sensors are very important for the athletes. So that will tell you about what are your physical activity tracking. Motion analysis can be done using these IMU sensor. Then we know SpO2, the blood oxygenation saturation level. Then body temperature, skin temperature can be measured, stress level, step monitoring, how many steps you have walked each day. And also sleep patterns can be analyzed using wearable devices, because it is very, very important that you should have a very good sleep. But we cannot quantify, how well we have slept. We cannot quantify. So if you have some wearable devices, so from the heart rate and from the movements that you make, the motion analysis is being measured, and from that it is trying to even categorize the sleep stages as light sleep, deep sleep, and REM sleep. Okay, like that. Then activity level, using motion sensor, you can measure the activity levels and the number of calories burnt. So based upon the motion tracking, it will say how many calories are burnt that particular day. And then the eating habits, foot pressure measurement, very important for diabetic patients. Foot pressure, they need to, because you know the complexities in what happens in diabetic patients. If they are not aware of the blood glucose levels, variations in the blood glucose level. When the blood glucose level is high, the, their foot pressure also increases. So when you measure the foot pressure, and when we are able to identify that at an early stage, immediately you can give treatment so that all these sores or wounds can be avoided. Then gait analysis, as I told you, the motion analysis, movement analysis can be done using wearables. So if you see here on the left side, these right side are the parameters. Left side, what kind of devices will be used to measure all these parameters? So here we have smart glasses. So smart glasses will have a display here. So all notifications that comes to your mobile can be displayed in this smart glass. So that when a person is going for a jogging or what to say, some exercise, so they need not every time see the messages in their mobile phone, or they need not carry the mobile phone. The smart glasses will pop up all the messages to them. And then smartwatch, we have seen smart shirt. Okay, the fabric itself is smart, which has the sensors in it, so that if you just wear the fabric, it's going to uh, acquire the data and transmit. Then GPRS can be picked up, and Bluetooth key tracker. So generally, most of us will misplace the key and we keep searching them, is it not? So even the key can be tracked using Bluetooth. Then smart shoes. For diabetic patients, we can have sensors placed in the sole of the shoes so that it can be monitored. Are you all audible? Am I audible to you?
Yes, madam. Yes. Continue, madam.
Okay.
Continue.
So if you take a smart shoe, in the insole, these pressure sensors will be placed. So whenever a person walks, we exert the pressure. Is it not? When we walk, we exert the pressure. So directly, this pressure on the sole will be measured using the sensors, and we can. These sensors are wirelessly transmitting these pressure values to your Android phone. So having the phone in your hand, you can see, I will show that picture in the next slide, the forthcoming slide, so that it will say what is the pressure at particular site in your foot. And similarly, you have smart socks. So instead of shoe, you can even wear socks. The socks will have the sensor which will measure the foot pressure, and even the socks measures the foot temperature. Because even in diabetic subjects, when they have this foot pressure, they have high temperatures in that particular locations. So you can have, using smart socks, we can measure the foot temperatures, which indirectly tells you the higher foot pressures. Then smart pants, that's our fabrics. As I told you, belt can be used for measuring the respiration rate. Smart rings can be used to measure ECG, as well as even UV exposures. Ultraviolet rays exposures can be measured using the smart rings. And then smart finger. This is a miniaturized device that you can wear in your fingers, and two fingers, you can wear it in your two fingers, and when you move your two fingers, it will give you the measurement of the distance. Say, for example, you want to see how much is 5 centimeter. Generally, what we will show in our fingers, is it not? So if you wear these two devices and if you show the distance, it will measure the distance between the fingers. Smart bracelets, jewelry, I told you, the earrings and bracelets can also be used to monitor the vitals. So now we have seen what kind of the various variables we can go for. But what should be the design constraint? As an engineer, um, we should actually contribute in developing variables. Instead of knowing the applications, we are not in the user side. We are in the user side, but most of us have to contribute in the development of variables. So in that case, the engineering part is very important here. So before designing variables, what are the design constraints that we have to take it in mind? First thing is, uh, it is variable, is it not? So it has to be lightweight. You cannot have complex circuits. So that, because all these devices should be lightweight, then only it will be preferred by the customers in the market. And very important thing is the power consumption, because all these are real time, um, real time data acquisition, and everything is should be battery operated, because it should be safe. You cannot you cannot connect your variable to the mains, is it not? Is it safe to connect the variable to the mains? So all the variables will be battery operated, and so each stage you have to optimize the power consumption. Sensing stage, the processing stage, then the communication stage, everywhere the power is very important. So you have to choose devices such that you have to choose sensors, and you have to choose your processors, your microcontrollers, such a way that the power consumption is very less at each stage. So this is a very important design constraint. And very small physical profile. You cannot have a large weight is one important thing, but the physical size of that is the form factor of the wearable device, it should also be small, is it not? That is only liked by the population. Many people will like only the gadget should be very small. Okay, you cannot have a a 2 x 2 centimeter device, or a 5 centimeter device. You cannot have such kind of a large physical profile devices. Nobody will be willing to buy such devices. So the physical profile of the device should be very small. The power consumption is a very major factor, and lot of research is going on in power consumption. Easy user interface, because it is being largely used by the population. So you cannot you cannot say that everyone should be educative about it. So easy user interface is required, so that every person can be familiar to use the device. And it should be flexible. It should conform to the shape of the body. Because if you design some patch, for example, if your patch will conform to the shape of the body. If it is a rigid equipment or rigid device, and you have to see about the shape, how it fits on the human body. That is very important. The flexibility, and then easy to install and set up. Okay. And the material that you use, because it is owned by the humans, it has to be friendly, or to say biocompatible. There should not be any hazard. The material should not create any skin irritation or allergies. And finally, it should be electrically safe. There should not be any electric shock or any short circuit that is happening. So generally, when we do conduct some circuits in our labs, what will happen? Immediately some circuit element will, what to say, it will burn. And so such things should not happen in a wearable device because the humans are wearing it. So all the design factors are shown here. So whenever you design a wearable, depending upon the application, first thing, depending upon the application, you have to select the sensors. Okay, what kind of application I'm going for? If I'm going to design a fault detection system, we have to choose a IMU sensor, inertial measurement unit sensor. If I am going to measure the SpO2, I have to use a LED and a photo detector, infrared LED and a photo detector to measure the pulse rate and other things. So if I'm going to measure the, so what kind of parameter, respiration rate, accordingly you choose the sensors. So generally MEMS based sensors will be used because all our devices should be very small. So we have to be very careful in the miniaturization. Even all our electronic circuits should be uh, miniaturized. Then connectivity, because very important, when I say IoT enabled, it should be Wi-Fi or Bluetooth connected. So connectivity is very important. Then ergonomics factor, okay, how it is being used. Then interoperability, the platform with which you develop the algorithms is very important because it should be compatible when you connect many devices. Because when you come to IoT means Internet of Things, many devices will be connected. Okay, say for example, motion sensor is a different sensor. Then you have ECG sensors, you have various sensors, and all these sensors parameters will be communicated. So there should be interoperability between the devices. Then the power should be power factor. What is the power consumption in each stage? That has to be taken care of. And the privacy is the most important thing. Because when I say all the data being stored in the cloud, they are being transmitted and stored in the cloud. So there is a chances of stealing the data or data breaching is possible. So privacy factors and so cyber security is very important here. So the stages, as I told you, there is 3 stages in any wearable device. First is the sensing stage. Second is the processing stage where you digitize and do the processing. And then finally, some amount of data will be stored in the device itself. And later on, you can connect this device to your computer and retrieve the stored data. And this is a very important aspect. Is the final stage is the wireless transmission. Either Wi-Fi or Bluetooth will be used. And as I told you, power. So generally batteries will be used. Lithium ion batteries and solid state batteries are generally being used. And we would have heard of energy harvesting. Now, most of the research is going on in energy harvesting. So even these wearable devices, the energy can be harvested, and those energy and that energy can be used by as a it can be fed as power to these wearables. So generally, we can harvest energy from light, from the environment. So from the heat in the environment, from the light, and then from the motion, because kinetic energy can be converted into electrical energy. So that kind of a principle can be used. So this kind of conversion of energy from the surrounding environment, which is found in the form of light, heat, and motion, uh, so the power can be yielded from this, which is called as energy harvesting. So even in the wearables now, they have started to use these kind of harvesting techniques. Like we have thermal energy harvesting, vibration energy harvesting, and solar energy. So what is thermal energy harvesting? The word thermal itself, we know it is heat. So the heat from the surrounding environment is picked up, and from that the energy is being generated. For that, thermoelectric generator is used, which converts the heat into electrical energy. Then vibration energy harvesting, we know the piezoelectric transducers. So the kinetic energy, there is a kinetic energy that results from the motion. So even when you walk, we have kinetic energy. When you run, we have kinetic energy. So all our movements, from our movements, these kinetic energy can be picked up, and we can convert that into electricity. So you can use piezoelectric sensors for that. And solar energy, we are all very familiar with. So from the sunlight, using photovoltaic cells, you can convert sunlight into the electricity. And the solar energy, we all know it is the most successful form of energy harvesting. And the next important thing is the processing. So how this processing unit should be in a wearable device. Because what kind of processing we do pre-processing. We have to do whatever some amount of noise may be there in the acquired signal. So the noise should be removed and you have to process the data. Some algorithms should be implemented. Okay, some thresholding algorithm, because even from the wearable devices also you will get alerts. A beep sound will be there whenever it exceeds some thresholds. So some kind of minimum processing will be done in the device itself. Because if you take, for example, Apple smartwatch, you have heart rate, you have temperature. So just like that, from the sensor will not directly give all these digital outputs for the display, is it not? So all this processing will be done in the microcontroller unit. So the microcontroller unit will have a ADC, which will convert the analog to digital signal. And then this microcontroller unit will have the CPU to do the processing, onboard processing. And from the microcontroller, it will be transferred. It will have a Bluetooth enabled, it will have a Wi-Fi. So it will have a communication module. So through Bluetooth or Wi-Fi, you can transmit. So generally, these microcontrollers, when you choose for implementing a wearable device, you have to see it should be of low power consumption. So the preferred microcontrollers are Texas Instruments MSP 430, then Microchip PIC 18, PIC 12, then ST Microelectronics, then Atmega microcontroller. Then finally comes the data display and communication. As I already told you, the wearable gadgets will have minimum display in the device itself. So it will have a LED display or an LCD display. So minimum parameters will be displayed in the device. And later on, these parameters will be transmitted through the Bluetooth, generally to the smartphone. And we have the Android app where it will do all the monitoring and tracking. So, and the communication can be through uh, Bluetooth, Wi-Fi, or near field communication. So here we are going to see now some applications and some real world examples and commercially available wearable devices that are in the market. So here you can see smart socks. I have been telling, we have seen how smart socks is used. Here you can see these are all pressure sensors. The FlexiForce sensors are there present in the socks. So when you walk, the pressure will be measured, and you can see in the Android app, you can see the pressure points. So directly, it will in real time, you can see what is the pressure that is observed. So you will have green whenever the pressure is normal at a particular point, and the color changes to red when the pressure is high. And here you have a UV ring. So this is an ultraviolet ring. So the ultraviolet exposure, because now here in India, we don't bother about the UV exposure, but in the Western countries, the UV exposure is very high, which leads to cancer. So there, the requirement is more. So sensing element is placed here. So the sensor senses the ultraviolet exposure, and the display will be in the your mobile phone. This will be paired with the mobile phone and transmits, because in this kind of miniaturized rings, you cannot have a display. So a display will be in the mobile phone. So here you can see a person wearing socks with the sensors. So these are all temperature sensors. So even in the sitting posture, the temperature can be measured, is it not? So whenever before they get some wounds, ulcers in their foot, there'll be an indication of high temperature. So easily it can be picked up by using the temperature sensors. And here you can see a elderly person using a Google Glass. So it actually assists them. Supposing if they have some what to say mild eye problems, so this Google Glass will give you a better display. Here you will have a display screen. It will give a better display of what they see, uh, what is in front of them. So it will give a zoomed display so that they you can have a assisted living condition. And the very important thing is for the infants, how to monitor the parameters continuously. You cannot have devices being connected to these individuals, uh, to these babies. So simple, lightweight devices are required to monitor the vitals of the infants. So here you can see a commercially available socks. This is called as owlet socks. So it measures uh, heart rate and as well as the heart rate and the uh, blood pressure. So the applications can be anything. As I told you, you can go for chronic diseases, assistive technologies, mental health conditions, and all medical conditions. One of so we'll be seeing one by one. So for diabetic, how this particular device, sensing device, is being used. As I told you, this is a closed loop system where you have a sensor. Here you can see C is the sensor and A is the processor, or we can say a mini computer, which has a processor as well as a pump to administer the insulin. So here you can see C. C is the sensor that is placed in the abdomen. And generally, glucose measurement, how normally glucose measurement is being done. Invasive method, where a prick will be done, and from the drop of blood, you will have a sensor uh, patch. So that is placed, and using the calorimetric technique, it will measure the amount of glucose. So every time the patient, whenever they need to know the glucose level, they need to prick and find out from the blood only. It is an invasive method, and you know what are the difficulties. If they're diabetic patients, daily they have to do that. And for and if you want to monitor continuously, you cannot do that, is it not? So for continuous monitoring, it is not at all possible with the conventional systems, glucometers. So here it is an IoT enabled wearable device. This sensor is placed in the abdomen. So this sensor will measure the glucose from not from the blood, but from the interstitial fluid. This fluid is present beneath our skin. So it is not sensing the glucose level from the blood, it is sensing the glucose level from the interstitial fluid, which is the fluid between the tissue, below the tissue, between the body tissues, we have the fluid. And it measures the sensor, it measures the glucose level. And the glucose level is transmitted wirelessly to the device here. This device will, from the glucose level, because here you should have all the processing, because it senses here you should have all the processing to find out the glucose level, and this glucose level will be transmitted wirelessly to a device here. This device A is a computer where from the glucose level it will map the the amount of insulin which is required for the patient. So from the diabetic patient, from the glucose value that is measured, this A will I find out what should be the insulin that has to be administered for the given value of glucose. Once that is known, here you can see a cannula being attached, uh, a cannula here. So here there is a pump, a miniature micro pump is there. This will pump the insulin, and through the cannula, it is being taken and it is administered to the patient. So this is a continuous process. It not only measures the glucose, it also, based on the glucose level, it identifies the what to say, it identifies the amount of insulin to be administered. Not only identifies the amount of insulin, it also administers. So here you will have a what to say, the insulin is stored here, and through a pump it is being administered. So here you can see a picture. Uh, So during sports, you can see she's wearing a Google Glass, a smart glass in which you will have the notifications, whichever you get in your smartphones. And you have activity trackers, that is IMU sensors can be placed. And in the body, in the fabric itself, it can be placed. IMU sensors, that is motion sensors. And you have smart shoes so that you can find out how much amount of pressure they exert during running. And smart watches are there. So this is an example. So you will see multiple devices are now connected to a subject. So there should be interoperability uh, for the devices. That is one of the challenge in IoT. And I told you activity tracker. So sports personnel, it is very important, the number of steps that you walk. So based upon the motion sensor, it will identify the number of steps that you walk. And it will not only give the number of calories burnt, it will also tell you that the posture will also can be measured. The sitting posture, the standing posture, or whether you are in movement, whether you are in walking. Say, for example, you are sitting for more than half an hour. It will give a kind of a what to say pop-up message that you have to go for a walk, or you have to. So all these kind of automation can be done. See, here is a smartwatch which tells you you have to drink water, you have to stretch now, you have to go for a. See here, it will give you what is your um, levels, sitting posture, what is your position, in standing, how much amount of standing position you have done. So like this, you can have a feedback. And this is again for a rehabilitation also, the wearables are being used. And in here you can see the pressure sensors are being placed in the um, sole of a shoe. And this will tell you the posture. It will tell you because for patients who are affected by stroke, now they are in the rehabilitation phase. So it will be very difficult for them to even have 2 or 3 steps. So, so for them, if you give a feedback that through the pressure sensors, you can give a feedback about their posture and activity. So that will be a motivation for them to enhance their rehabilitations. And here you can see a skin patch. So from the smartwatch here, you can see a skin patch. See how miniaturized skin patch it is. And this skin patch will have all the elements that I have told you. The sensing element, uh, the processing element, the communication element, everything this particular patch has. And you can see in the Android phone, you have the Android app. So you can see the ECG being picked up from the patch. So if it is a patch, it will be you will not even feel that some device is being connected, is it not? So continuously you can monitor the parameters. And here is a picture where you can see a weightlifting person uses 10 motion sensors. I've told you what is motion sensor. It will have accelerometer, gyrometer, which will give you the acceleration as well as the angular velocity. So it will give even the joint motion, joint angle, how the hand has been stretched, what is the joint angle. So all these parameters can be measured and their performance can be optimized. To optimize their performance, these sensors are being connected. So in the fabric itself, you can have sensors as well as if you see these are all motion sensors connected in various joints. And here is another example. Instead of doing physical rehabilitation, generally physical rehabilitation will be done wherein you have a physiotherapist will come, uh, will have a physical contact with the person and they will teach the physical exercises. But here you can see you have a wearable device, the person wears a wearable device, and in the Android app, you have the exercises. So he just sees the exercise. So his leg has to be stretched at an angle of 45 degree, has to do that. Now this device picks up the angle, everything, the joint angle. It is an IMU sensor. It picks up, not only picks up, in real time, he can see the He can have the feedback how he is doing it. Here you can see a bar, is it not? So in the bar, it will tell you how far he has done, the percentage of how effectively he does the exercise. So not only he sees the exercise protocol in his app, in real time is able to even get the feedback how well is being done. So without any supervision, they can do the exercises. And next is biosensors. Biosensors is nothing but here we'll have whatever we have seen so far is more of electronic sensors. Here it is chemical sensors. So you will have analytes, which are, say, for example, glucose or lactate. All these things can be measured. The sensor will be in the form of a patch, which will have a chemically sensitive layer. This chemical sensitive layer will interact with the sample. Say, for example, glucose will be there in our sample. Glucose will interact with the chemically sensitive layer, and there will be a chemical reaction. And based on the chemical reaction, uh, electrochemical using the electrochemical principle, this can be converted into a voltage. Once it is converted into a voltage, you can measure what is quantitatively, you can measure the output. For example, show the example. So what are the various biosensors that are available? You can measure lactate, glucose, the cortisol levels. So it will be in the form of a patch. Even you can have a graphene based tooth sensor to measure the bacteria levels in the tooth. You can have a sensor as a mouth guard. As a mouth guard, you can reach the mouth so that the sensor is placed in the mouth guard. It measures the uric acid. And through contact lens, you can measure the glucose level. Okay, so all these are, so here you can have a sensor array which measures the glucose. So how it is being done? So here you can see a patch which does continuously, it monitors the glucose. So at various different time intervals, you can see what is the glucose level. So how it is being done? So the glucose will, the enzymatic reaction takes place. For example, if the sensing layer is a glucose oxidase, it catalyzes the glucose in the patient into gluconic acid and H2O2. So this hydrogen peroxide is measured electrochemically, and this electrical signal can be then proportionally converted into glucose concentration. So you can see from the interstitial fluid also you can measure the glucose, as well as from the sweat also you can measure the glucose. So here you can see in the Android phone, you can see wirelessly the sensor. It is only a patch, but you can see how much amount of sensing is there. A biosensing layer and electrochemical reaction takes place. Then this electrical value, from the electrical value, it decodes and quantifies the amount of glucose, and then this amount of glucose is transmitted wirelessly to the Android phone. And see, here you can see how virtual reality can be used connected to IoT. And this can enable as a treatment strategy for autism children. And even you can use IoT enabled devices for neuro applications, like because you nowadays you have EEG devices which are wearable, and they can wirelessly transmit the EEG signals. When they can wirelessly transmit the EEG signals, you can have develop algorithms, and you can have developed devices so that automatically you can detect epilepsies before their occurrence. The Parkinson's disease can be detected, or you can develop BCI system to control the prosthetic limb or exoskeleton or wheelchair. It can be used to detect migraines, multiple sclerosis. And here are some of the devices. Quickly, I will show you because already we are in 7:20. So some of the commercially available devices, here you can see a band. This is a Whoop band. It monitors the stress level as well as the sleep stages. So what is the sensor that is there? Uh, it measures the heart rate. So it measures the from the photoplethysmography signal, it measures the heart rate variability. So from heart rate variability, it measures the stress. And based on the accelerometer, it analyzes the movement patterns and it categorizes the sleep as light sleep, deep sleep, and REM sleep. Here you can see. So every day it finds what is your time, at what time you're sleeping and what time you're waking up in the morning. The application will give you all this, it will track your sleep and also how much amount of your performance is there, whether you had an optimal sleep. And here it categorizes sleep as whether how much time you were awake, whether it was a light sleep, whether it was a deep sleep or a REM sleep. REM sleep is rapid eye movement sleep. And here I told you the glucose sensor, continuous glucose monitoring sensor, how it is placed in the uh, abdomen. And you here it is only monitoring device so that your Android phone will get the glucose levels. Continuously you will get the glucose levels in your Android phone. Here is a smartwatch which gives you the pulse rate as well as the systolic and diastolic pressure. And this smartwatch also gives sleep tracking. And here you can see a pulse oximeter. Everyone has used a pulse oximeter, but this is a IoT enabled pulse oximeter. So you can see in a mobile device, in your mobile phone, you can see what is the SpO2 level, percentage of oxygenation, and the pulse rate is also given. And this can be connected through the Wi-Fi. It can be connected to the cloud. And here is an example of smart medication device, a smart pill tracking system. So the pills are, so I told you the pill will have a tag. So the pill has a RFID tag and here you have a scanner. When it scans, it reads the medication. What is the medication it gives? And all this, once it is scanned, this information will go to the caretaker. So before taking the pill, just the elderly person should scan the pill bottle here over the reader. So it will scan what is the name of the medication. Directly this information will go to the caretaker as well as to the patient. And also it gives the alert. 9 a.m. we have to program that so that it gives alerts and it gives the reminders. This is a smart inhaler, very important and very important for the asthma patients. So smart inhaler in the sense it will give a track of how you have used the inhaler, how much time you have used the inhaler, and you can even program the dosage and see whether it was properly administered. Even there are smart implants. You know, the pacemaker is a uh, you can implant in the heart, but this is a smart pacemaker. So it is a wireless pacemaker. It can be programmed as well as it can be monitored. So you can monitor the battery levels and you can also monitor how is the performance of the pacemaker, how much is the energy that was delivered. Okay, all that can be monitored by the clinician. Now, neuro implant. For epilepsy patients, this small miniaturized device can be implanted so that continuously it measures the EEG signal. And if there is an abnormality, it gives some electrical stimulus. So when there is an abnormality in the EEG signal, it gives an electrical stimulus through the electrodes so that immediately it avoids the epilepsy. So it prevents the epilepsy being occurred. Then I told you the equipment itself can transmit the parameters. This is this is an patient monitoring system which is being used in the ICUs. So when it is smart, all these parameters which are measured in the bedside will be transferred to a control unit. Where sitting in a nursing station, a particular doctor can view or particular nurse can view all the parameters, not she need not come and visit every patient. In a centralized system, all these parameters can be monitored. Now every device, the patient monitoring system device itself is a smart device. And this is a smart infusion pump. You know, infusion pumps are used to deliver the medications. So even the infusion pumps can be smart so that you can program the device and you can give a medication, how much amount of medication has to be administered. And also you can monitor the device. whether the medication is properly being administered, what is the rate at which it is being administered. Everything will be transmitted from each infusion analyzer. And here you can see IoT enabled diagnostic device. Example, a commercial device, you have Cardia Mobile. Just you have to place the fingers and you can see the immediately in the Android app, the ECG is measured and all these arrhythmias can be identified. It will give even the arrhythmia, whether it is normal, whether it is atrial fibrillation or bradycardia or tachycardia. And here you can see a diagnostic device, a smart ultrasound device. In our lifetime, we would have gone for an ultrasound test. So here it is a smart ultrasound device. The monitor is only your mobile phone application, Android app. So you can use a handheld ultrasound device where you can see in the smartphone, you can have the image and this can be transmitted to the clinician. And so now in the robotics field also, we have heard of Da Vinci surgical system. In the robotics surgeries also, these parameters for remote surgeries, you can use these things, IoT enabled devices. And telemedicine, see here is a kit for telemedicine. A person who is sitting in the remote place, if just they'd use this kit will have stethoscope, camera, otoscope is nothing but used to monitor the ear and the eardrums and the tongue depressor. So from using this kit, you can measure the heart rate, lung breathing sounds, all this ear canal, eardrum can be viewed. All this can be connected and all this information will go in real time to the doctor who is sitting in the remote place so that he can give some, uh, he'll be giving a personalized treatment. So having seen all this, what are the challenges in developing the wearable devices, the motion artifacts? Because in day-to-day life, we are using all these wearable devices. So there'll be motion artifacts and accuracy. Whatever the parameters that the wearable devices that are giving, they are not accurate. Or I can say that they are not clinically accurate. Okay, it is only a approximate value. They are not clinically accurate, graded. And data security, you know what is the problem because you're doing transmission of all the data to the cloud. So you have data security and privacy challenge. Then there is a need for stretchable and skin attachable electronic devices. And lightweight signal processing has to be done. What is meant by lightweight? You know, lightweight device is okay. What is lightweight signal processing? The algorithms that you design should be of, it should not, what to say, more amount of, it should not take more amount of CPU power. The processing power, the number of computation should be less. So that is what is lightweight signal processing. And then ultra low power requirement. I told you the amount of power required should be optimized. And then interoperability, the number of, because you are using multiple devices, you have to integrate all the multiple devices and each one of the devices operating in different protocols and all that. So now what is the future of IoT? Now you know what is the present state. What is the future of IoT? So you're going to, so it is going to revolutionize the healthcare by employing the artificial intelligence. Now you have 5G networks, the advanced sensors in MEMS also there is so much of advancements and the electronic side. Okay, so put together it is an integration of electronic sensing, communication, and also the emerging technologies, that is artificial intelligence. So it is all going to accelerate the IoT innovations. You're going to get many more IoT enabled innovative devices in healthcare. And so because of this, you're going to have precision medicine very accurately. You can give diagnosis, real-time surgical assistance is possible, and more analytics can be developed. Predictive analytics is possible. And finally, all this information of a patient should be integrated with the patient's electronic health records. That is more important so that the finally the electronic health record will have all its parameters that are being measured. So thank you. I think I have exceeded the time also. So if there are any questions, any feedback from your side, I'll be willing to take up.
Participants have any questions? There are, I can see two questions from Mohammed Main.
It is in the chat. Okay, okay. I will see.
Please see chat box.
Okay.
Apart from pressure sensor, what sensor are used in smart shoes?
Apart from pressure sensor, what sensors are used in smart shoes? Smart shoes, we have flexi-force sensors. When I say pressure sensor, they are not, they measure the pressure, but they are all force sensors. Flexi-force sensors are being used, and they are available at different sizes. Generally, only flexi-force sensors are used in the foot pressure measurements. That is a successful methodology. And then whether neuro implant device is practically used or it is in research stage. I know a neurologist who used this neuro implant device. They are using it for dementia. It is currently being used even for patients who are alcoholic are getting this neuro implant device, and stroke affected patients. Currently it is being used. More than a decade, this neuro implant devices are being used. Only thing is this neuro implant device is very expensive because the device itself is around 15 lakhs. So that the surgery takes around 30 lakhs. So common people, they cannot afford so much. That is the problem there.
From participants, if anyone have question, they can raise their hand. So unmute them. Hello. If participants have any question, they can raise their hand.
Example of biosensor, that's what I was telling about the glucose sensor. The glucose sensor and the lactase measurement, all these are examples of biosensor. And if there are any questions, what is the effect of electromagnetic interference by wearing these sensors in cloth? That's what I told you. Electromagnetic interference will be there. That's why we have to do the pre-processing. Because these high frequency noises have to be removed. So the microcontroller, we should have the pre-processing where we use the low pass filter and eliminate all the high frequency effects before processing the signal.
Can you give some example of invasive sensor? Pallavi Panthare.
That's what I told you about the implantable pacemakers and neuro implants. They are all.
Mitesh, one raise and please unmute him. Hello, Mitesh.
Yes, sir. I put a mic no allow. Mic allow किया है sir. Yes.
Good evening, madam. I got the answer. That's what I was asking you about the electromagnetic interference.
Yes,
because
during pre-processing we have to.
Because we are using the sensors means they produce electromagnetic waves.
Yes, these high frequency noises have to be removed by using low pass filters initially before doing any further processing.
Okay. Thank you, madam.
So even if there are any questions at a later stage, I'll be willing to take. I'll share my mail ID.
To madam.
I think sir has
email ID. I will share your email ID.
Yeah.
Okay.
Yeah.
Madam, please share all these presentations, madam. They are very useful.
Okay, sir.
Share the entire presentation to the participants.
Okay, sure.
Okay.
I'll share.
Thank you.
Thank you, sir.
Thank you very much, madam, for time, and you have accepted our invitation for the expert speaker. and you have share all knowledge about this IoT in healthcare, role of IoT in healthcare. And this is very informative and detail-oriented session. Participant can gains detailed knowledge about IoT, how to use IoT in healthcare. So thank you, madam, again.
Thank you so much. I thank the organizers for giving me this wonderful opportunity. And also I thank all the participants for your interest in this topic.
Please, one group photo, please, madam. I request to all participants, please turn on your camera so we can take group photo. Madam, please unshare your screen.
Yes, once again.
I request all participants, please turn on your camera so we take group photo. Okay, thank you. Thank you.
Thank you so much. Thank you.
Thank you, madam. And now you can leave or stay.
I'll leave now.
Okay, thank you, madam. Thank you.